Hello, this is the walkthrough video for PCTC 2022-2023 round 2 question 11 ordering sevens. So this question essentially gives us a number, for example 85, and it asks if we were to write out every number from 1 to 85, how many sevens appear? And so I guess the obvious solution to this problem would be writing a for loop from 1 to 85 and counting how many sevens appear in each of those numbers. But this is question 11, so it's obviously not going to be that easy. And so if we look down here to the constraints, it says n will satisfy and is bigger than 1, which is obviously fine, but n is up to 10 to the power of 100, which is a huge number. So if we write our code as a for loop, just as I described, which is the obvious solution, that's not going to run in under 3 seconds. It's going to fit the memory requirement, but it's not going to run in under 3 seconds. And so we need to think of a better solution here, a solution that runs in 1 or 2 seconds ideally. So I guess the next thing you might think of is to not go from the number 1 to the number they've inputted, for example 85, but to look at the digits in the number they've inputted. So let me just describe this. For example, if we had the number 245 and we wanted to calculate how many sevens appear from 1 to 245 inclusive, then instead of writing a for loop from 1 to 245, we can look at each of the digits individually. So we can look at 5, we can look at 4, and then we can look at 2. And we can figure out how many sevens are in that position. For example, if you were to look at 5, how many sevens are there from 0 to 5? So this is a units column. How many sevens are there from 0 to 5? Well, in this case, there are 0. Now if you look at the 4, this is the tens column. How many sevens appear from 0 to 40? And that's a slightly harder question to answer. So how many sevens appear from 0 to 40? And we'll do that calculation a bit later. And then finally, if you look at the 2, now we're going to ask ourselves how many sevens appear from 0 to 200. And I guess for completion, let's just write that. So what we're doing, instead of writing a for loop, we're going through each of the digits in our number and trying to figure out how many sevens appear from 0 to that digit, including like the amount of the power of 10 that is 2. For example, this is just a units digit, this is a tens digit, this is a hundreds digit. And the reason this is going to be way faster is because at most, our input number is going to be 100 digits long, because as we saw, the maximum input is 10 to the 100. And so we're only going to have to do this computation, for example, 100 times, as opposed to 10 to the 100 times. And so this is going to be a much faster method. So now the next question you're going to ask is obviously, how on earth do we figure out how many sevens appear from 0 to 5, 0 to 40, and 0 to 200? And now let's tackle that part of the problem. So, as always with these problems, unless you can see an algorithmic solution instantly, it's usually always best to start off with an example. So in this case, 245. And then you want to work out the answer to the example by hand and try and spot a pattern and convert that into an algorithm and then convert that into code. So how many sevens appear from 0 to 5? That's obviously 0. How many sevens appear from 0 to 40? Well, there's going to be 7, 17, 27, 37. That's 4. And that's it. That's 4. And how many sevens appear from 0 to 200? That's going to be 7, 17, 27, 37, 47, so on, all the way to 97. Well, all the way to 197. And then there's also going to be 70, 71, 72, 73, 74, 75, 76, 78, 79. And same for the 100. So 101, 170, 171, 172, and so on. So in total, there are going to be, I believe, 40, if I'm correct. Yeah, that sounds right. And I'll just write them down now quickly, in case you're wondering what they could be. So there'd be, for example, 7, 17, and so on, up until 197. And so that's going to be equal to 20. But you also get, you also get, let's get rid of that. You get 70, 71, 72, all the way up to 79, and that's equal to another 10 sevens. But then you also get 170, 171, all the way to 179, and that's equal to another 10. And so that's how in total we have 47s from 0 to 200. And so our next task is, how do we find an efficient way of calculating these numbers, right? Because if you can calculate them really efficiently, then our code is going to run very, very, very quickly. And this is a much harder question to solve, and we might have to like think about it for a while. And feel free to pause the video now if you want to have a think about this for yourself. This video is going to be much more useful to you if you spend just a couple of minutes every now and then to pause the video and have a think and play around with the numbers. Okay, so how do we calculate this? And here, the key insight is to spot that we're looking at the units digit, then the tens digit, then the hundreds digit. And so what we can say is how many sevens appear from 0 to 10, for example. So from 0 to 10, there's 1 7. And so that's going to mean from 0 to 40, there are 4 sevens. And let's just write that down. From 0 to 40, that means there are going to have to be 4 times 1 sevens, which equals 4 sevens. And of course, as we saw down here, that's correct. And we can apply the same logic to 200. So from 0 to 100, how many sevens are there? Well, as we saw down here, there's going to be, oh, we didn't see down there, but using the same logic that we used down here, we can calculate by hand pretty quickly that there are 20 sevens. And so that means from 0 to 200, which is just double 100, that's going to be 2 times 20 sevens, which equals 40 sevens. And of course, that's the answer we got down here. And so now you might recognize the key idea, which is if we calculate the amount of sevens that are in from 0 to 10, that there are from 0 to 100, that there are from 0 to 1000, all the way up to 0 to 10 to the 100, then we can try and figure out a solution to this. So the next question you now have is, how do we do that? How can we quickly calculate how many sevens there are from 0 to 10, from 0 to 100, from 0 to 1000, and so on? Now, when I was solving this problem, I actually had to do this, and then I went from 0 to 1000 as well. And that's when I spotted the pattern. So again, if you want to pause the video and do that for yourself, you might spot the pattern. But if not, I'll show you the pattern now. So, and you can think about it logically, right? So if, for example, I'm going from the 0 to 100, and I want to do the 0 to 1000. So the 0 to the 100, let's assume you already know the answer to that. Let's assume you know the answer is 20. And we do, because that's really easy to calculate, so we just did that by hand just now. Now, how do we get the 0 to 1000? Well, if you think about it, there are 10 100s in 1000. And so there's going to be 10 of those 20s from up here. 10 of those 20s, because there are 10 100s in 1000. But we also have to count for the series of 700s, right? Because this doesn't account for all of the sevens that you get because of 700, 701, 702, 703, and so on. And so there are another 100 of those. So that's going to be, let me write that down as well. That's going to be 700 to 799. Oops. 799. Let's make that clearer. Okay. And we can then notice that the pattern is going to be the previous one times by 10 plus like the thing of the previous one. So just to show this pattern in action, how do we calculate the amount of sevens from 0 to 10,000? Well, that's going to be the answer to this, which was 300. So that's going to be 300 times 10 plus 10,000 plus 1,000. And we've just applied the same algorithm that we did up here to these two. And so we get the answer to this is going to be, I think that's 4,000. And this is how we calculate the number of sevens there are from 0 to a power of 10. And so let's implement this in the code right now. So let's think about that. We've got, so let's create a list of sevens, a count of sevens, and we essentially want to build up our list to store this information. So we want to say how many sevens are there from 0 to 10, how many sevens are there from 0 to 100, how many sevens are there from 0 to 1,000, and so on. And so that means we need a starting point. And so our starting point, let's say, is going to be 20. No, not 20, it's going to be 1. Because to calculate the next digit, we need a starting point. Because like this algorithm is a recurrence relation, right? It's each new calculation depends on the previous calculation's answer. And so we need to manually calculate one answer, and also manually calculate one answer, then we can get the computer to calculate the rest. And so the answer we've got in here is how many 7s are there from 0 to 10? Well, there's only one 7 from 0 to 10. And so that's that answer. And so now we can do, for I in range, and we want to go from 10 to the power of 2, because that's 100, to 10 to the power of 100. And so that's how I do 101, because it's Python. So that's a range we need. And what do we want to do? We want to take the previous answer, so that's going to be 7s minus 1, which is the last digit we've added to, the last number we've added to the list called 7s. Let's actually change the name because I'm going to be saying 7s a lot. So let's say pre-calc, because that's what we pre-calculated. So we're going to take the last pre-calculated value, and then we're going to apply this algorithm. So that's going to be multiplied by 10. So pre-calc multiplied by 10 plus 10 to the power of something. In this case, that's 10 to the power of I because of how we've defined our range. So that plus 10 to the power of I. And I believe that's correct. Nope, that's not correct. We need 10 to the power of I minus 1. So let's just do that. And what do we do with this answer? Well, let's just append it to our pre-calculation list. And so if we run this loop a load of times, or if we just run this code, I guess, then we're going to get a list called pre-calc, which basically pre-calculates the amount of 7s there are from 0 to 10, 0 to 100, 0 to 1000, all the way up to 0 to 10 to the 100, which is excellent. So, and this code is going to run in milliseconds, probably less than a millisecond. I don't know how long this code is going to take to run. But it's very easy just to run multiplication and 10 to the power of something and addition for 100 times. So this code is going to be really, really quick, and that's good. Right, so we've done our pre-calculations. Now let's do the implementation. And as we discussed right at the beginning, our goal is to go through every digit. So we're going to go through this digit, then this digit, then this digit. So let's import our number firstly. So let's say num equals int input. And actually, we're not going to make an integer like you would otherwise think, because if you want to iterate through every digit in our input, then if you make a string, it's much easier because you can't iterate through every digit in a number. You can iterate through every digit in a string. So like we're just iterating through every character in a string. So let's keep it as a string when we input it. And now let's do the iteration. So for I in range, and just because it's more intuitive, let's start from the right because it's units. So we want to go from, let's say 1 to len num plus 1. And yeah, that should be good. And so now what this means is if I were to reference num minus I, I'm going to be referencing the digits from right to left. So for example, if our number is 245, and this is our range, so it goes from 1 to len num plus 1, then I at first is going to be 1. And so the minus 1th character of this string is 5. Then I is going to be 2. And the minus 2th character of the string is 4. And the minus 3rd character of the string is 2. And so hopefully that made sense. If it doesn't, again, just copy this code and have a play around with it, print stuff out at any stage. You might want to, for example, print pre-calc to see what we've done, or really anything you want. So num minus I is the digit we're currently interested in. And one thing I should point out is we need len num plus 1 here, because again, just like the problem up here, Python goes up to this number but not including this number. So we need to make this one more than the number we actually want. That's why this is 101, and that's why this is len num plus 1. Okay, so let's get our current digit using this basic code. And in this case, now that we've got the correct digit, we probably want it as an integer, because an integer is like how you do the math and the comparisons and so on. So now we've got a digit as an integer. Now what do we want to do? We want to apply this basic idea from before, where we take how many 7s appear from say 0 to 10, and we multiply that by our number, our digit. So actually we need a running total value, don't we? So total is going to start off at 0 at the beginning of our code. And as our code progresses, we're going to update total. So what are we going to add to total? We're going to add the algorithm I just said. So that's going to be digit multiplied by however many 7s appear in whatever digits column we're in. And so that's going to be taken from pre-calculus. And this is the harder bit. What index is that going to be? So if we think about, in this case, 4, for example, so at this point, I is minus 2, or sorry, I is 2. And we want to take the pre-calculation from 0 to 10, which is the 0th element. So it's going to be I minus 2. Hopefully that made sense. Again, if not, copy down the code, have a play around with it, see what does work, what doesn't work, and why that's the case. So now at this point, let's just print total actually. If I enter 245, I'm hoping this works. So let's just test that with 245. And what's the answer? The answer should be 44. Yeah, 44. And what did it give us? It did not give us 44. And why is that? We should probably do that. Let's run that again. Nope. Why is that happening? Live debugging, always good to see. So, in digit multiplied by pre-calc I minus 2. Surely that's correct, because I starts off at, oh no, that's not correct, because if I is 0, then this is going to complain, isn't it? Because I can be as low as 1, so if I is 1, then the answer to this is going to be minus 1. So it's going to wrap around and take the last element of the list. So this is not going to work. How do we solve that? The basic solution is let's just add 2 more zeros to the start, and that way we should be able to get rid of that essentially. And now let's run the code. And hopefully this shows, what was it, 44? Yeah, there you go. And so what I basically just did is, the issue when doing this, I minus 1 from pre-calc, is that, sorry, I minus 2 it was, is that this doesn't really exist. For example, like when I is 1, this is going to be equal to minus 1, which is not what we want. And so by adding an extra 2 zeros to the start of our pre-calc list, we just make sure that is zeros out and doesn't give us some crazy large numbers like we saw down there. Okay, again, if that doesn't make sense, experiment with the code. So far it works, but then if, for example, we were to submit this code, then it's probably not going to give us all 10 marks. And the reason for that, and you may have noticed this already, is there's a slight issue. For example, what if this number was not 245, but let's say we're now working with 285. Now, the issue with this number is that 8 doesn't, like this 8 is represents 80, right, in our algorithm so far. And so ordinarily our algorithm would do 8 times the amount of 7s from 0 to 10, that's 1, which equals 8. But we know that 80 contains more than 8 7s because this does not account for the 70, the 71, all the way up to the 79. It does not account for the 10 7s that we encounter in the tens column. And again, you may want to pause the video to have a think about this, but the reason, or I guess the fix to that is to check if the digit is above 7. And if it's above 7, like in this case, the digit is 8, then we need to add on, in this case, we need to add on 10, because we're missing 10 7s. We're missing the 10 7s from here. So we want to do a plus 10. And again, you may notice that this number is just 10 to the power of 1, or sorry, yeah, 10 to the power of 1, which is the same thing as this, which is 8 times 10 to the power of 1. Okay, so let's implement that in code. And just to confirm, yeah, we get no score because, essentially the way this grading works is if you don't satisfy the example input, then you're not going to get any scores at all. So if we were to run it with the example input so far, then we can see that the answer is going to be 8. So as we just actually pointed out, this is a good example. As we just pointed out, 8 is not the answer, right? It should be 8 plus the 10 from here. The answer is 18, and That should be what the example says, yeah. And this is the reason our code does not display 18, it displays 8. And so let's fix that. So let's check if digit is bigger than 7, then we need to add on that extra 10, or the extra 10 to the power of something. And so that's going to be 10 to the power of, and let's think about this, it's going to be, so in the case of 80, I is going to be equal to 2, but we want 10 to the power of 1, not 2. So this is going to be 10 to the power of I minus 1. And again, we should just do a sanity check to make sure this is going to work. So is this going to work when I is equal to 1? Because I mean, that's the issue we had up here, right? When I was equal to 1, the program broke. Is that going to be the same case here? When I equals 1, then this is going to be 10 to the power of 0, and 10 to the power of 0 is 1. Is that what we want? Yeah, that is what we want, right? Because that means if, for example, 8 is in the units digit, that's when I is 1. So when 8 is in the units digit, then yes, we do want to add an extra 1. So yeah, this should work. And so if let's run this code with 85, and hopefully this solves the problem, and hopefully we should get 18 printed out. Yeah, there you go, we get 18. And that's very good. But if I were to submit this code, we see another issue. And again, you may have already pointed out this issue in your head whilst watching this video. And yeah, see, we're not getting 10 marks yet because we've already got a wrong answer on test case 3 and some more wrong answers here. And the reason for that is, what if, for example, our number was not 245, it was not 285, but it was 275. Now what's the problem? The problem is we've got the correct number of 7s from there. We've got the correct number of 7s from there, which is 0. But we don't have the correct number of 7s from the tens digit. Because we've got the 0 to 77s, which is good, but we don't have the 71, 72, all the way up to 75. We don't have those 7s yet. And so if we were to, for example, run our code with 275, what should the answer be? Well, the answer should be 40 plus the 7 7s from that, so 47, plus the 5, no, more than 5 actually, because there's going to be 70 as well. So plus the 6 from there. So it should be, what's that, 53, I think? I might be wrong, it should be 53. But either way, we see it's not 53. Yeah, so it's missing the 6 7s that appear in this sequence. And that's why it's only displaying 47. So how do we count for that? Well, in our code, let's add yet another if statement. So if digit is equal to 7, then in this case, you need to account for this case. And how do we calculate that? Well, that's just going to be whatever number this is, right? So, well, whatever number this is plus 1. Because I guess as you imagine, what if we had as our input, let's say we had 270. Well, how many additional 7s do we have? We have 1 additional 7. So we need to add another extra 1 because of that. And so that's going to be our units digit plus 1. Hopefully that makes sense. And this logic actually applies, just to make sure it applies to bigger numbers. Let's say we had 750. So what's our algorithm going to do? It's going to say there are 0 7s there, which is good. It's going to say there are 5 7s there, which is good. And for this digit, how many 7s are there? It's going to be 7 times whatever our 100th value was, which was 20. So that's going to be 7 times 20. That's going to say it's 147s, which is wrong because that does not account for the 700s, right? So it does not account for the 7 from the 100th value, from 700, 701, and all the way up to 750. It does not count for any of these 7s, right? And how many of those 7s are there? Well, there's 50 plus 1. 50 plus 1. And just so you know, like why is there a plus 1? There's a plus 1 because we have 700. So we have 701 to 750 plus the also 700, and that's why it's a plus 1. Again, this is a really weird and confusing question, so feel free to pause if you need to and experiment. So if the digit is 7, what we want to do is we want to take our original number, we want to extract the rest of the number to the right of our current digit. So we want to extract from minus I, but I is, so we want to extract from minus I, but to the right of that. So that's going to be minus I plus 1. And we want to extract all of those digits. And let's turn that into an integer because that's just a string. And we want to add that integer to our total, plus the 1, of course. Oops, plus equals plus the 1. And now this should work. If we were to run this code, I think it should print out to 53. Perfect. But again, you may see another issue. And I'm not sure if this actually, let's try it. Let's submit the code. This might give us 10 out of 10. There's actually another issue with this code, which we can fix. Let's just see what score we get first, because you might not need to fix it. Yeah, so there's another issue on test case 9. So you only get 9 out of 10, which is still exceptional. We should be happy with that. But we want 10 out of 10. So again, feel free to copy this code, play around with the inputs, and see what you think test case 9 might be. But yeah, I'll tell you what test case 9 is now. So, well, I'll tell you what I assume test case 9 is. And that's the edge case where, for example, we get, let's say we have 17. Then what our code will do, of course, is, well, it does the 10 correctly, right? Because there's only one 7, which is 0, 7. So there's 1, 7, which is correct. But then from here, if we go back to our algorithm, it says if digit is equal to 7, then we want to do total plus equals the rest of the numbers. But like there aren't any more numbers, right? So our code is basically saying we want to add whatever these numbers are. But like those numbers don't exist because 7 is the units column, right? Those numbers only exist if 7 is not in the units column. Like if 7 is in the hundreds column up here, or in the tens column up here. But if it's in the units column, these numbers don't exist. And so this just gets confused, right? Because it's like this is not possible. And in this case, if 7 is the units column, then we ignore this code because that's obviously not going to work because these don't exist. So we ignore that, and we simply add the 1 because there's an extra 1 because there's a 7 here. Whereas if it was a 5, say it was 15, then we don't add the 1. If it was an 18, then we do add the 1, but that's counted for this. That's counted in those 2 lines of code. But we haven't yet counted if it's a 7. And so to do that, what we should do is we should say if digit is equal to 7, then we want to add 1, and let's remove that. Oh no, let's do this big, obviously. So we're going to say if I is not equal to 1. So this line of code basically checks if I is the units digit. So if we're currently looking at the units digit, so if you're currently not looking at the units digit, then we want to run this line of code because as we discussed, it doesn't make sense when it's units digit. But if it is units digit, then we still want to add 1 to the total, right? So we still want to do that. And hopefully now, if we submit this code, this should work and get us 10 out of 10. Let's see, that's hopeful. Let's see if test case 9 works. Yeah, so the rest, yeah, perfect, 10 out of 10. Right, so let's make this bigger. Can I make it bigger? Nope, okay. So this is our code. It's quite short, it's only 25 lines of code, but it's really, really complicated, right? It's question 11, what else can you expect? It's going to be hard. But like go over this code multiple times, think about it, and make sure you truly understand this idea, because I guess the first insight was to consider that we don't want to go from 0 to n. We want to go through the digits of n because that's going to give us a smaller search space to go through. And how do we do that? Well, we need to pre-compute stuff, like we pre-compute these. And just like that, using all of this information, we coded the majority of the problem. And I think that's what we did down here. We got 5 out of 10 for that solution. And then we had to think about, okay, 5 out of 10, that means there must be some test cases we're missing. What are those test cases? Those test cases are if a digit is equal to or greater than 7. And so all we did is I wrote an example down. I spotted the pattern and I turned that into an algorithm and I coded that up. I did that for both this case where it's bigger than 7, and this case where it's equal to 7, and even the case where the 7 is the units digit. And that's how we got the answer. But yeah, that was a tough one.